Hello, yeah, welcome today. Today, I just want to um, deal with some of those separation techniques we have in chemistry that someone normally confuses our children. The idea is to do it piecemeal by piecemeal. So this particular video is going to be focusing only on distillation and fractional distillation. Distillation and fractional distillation. What is distillation? What do you understand by the word distillation? Have you ever wondered how the petroleum that powers the car, the vehicles you use, are produced? Have you ever wondered how kerosene that you use in cooking your food is produced? Have you ever wondered how the gasoline, the diesel, some of these petroleum products are produced? Anyway, today we're going to learn about how this particular product, so wonderful product that have served us so far, we are produced and are being produced every day. Nigeria is one of the highest producers of crude oil. Let me say highest, dealers. We sell, they produce, they release. We have the highest abundance of crude oil in our land. So we are very lucky. And it is also important that we understand the process, the procedures that enables the production of such crucial, such important products like petroleum, or what we know as PMS.
So, okay, now let us look at the definition of distillation. Before I launch into the definition of distillation, I want you to understand that every separation technique is tailored towards a particular form of mixture. It's tailored towards a particular form of mixture. In the case of distillation, the mixtures involved, the components involved include mixable liquids. That's liquids that can comfortably mix together. Liquids that can comfortably mix together. Imagine if you put alcohol into water, they will mix comfortably. You will not know the difference by mere touching it or by mere looking at it. Now, if you put water and salt, they will mix together. Salt and water mix together. They will remain colorless. There will not be any difference in appearance. So for that reason, the way of separation of mixable liquids are different from the way of separation of immixable components, immixable mixtures. So today, the area in the case of distillation, it is important you understand that we are dealing only with mixable liquids. Liquids like when you mix kerosene and fuel, they mix together perfectly. You mix kerosene and fuel, they are all together. You cannot tell the difference. So how do you separate them? So now I am going to start the definition from the area of a simple distillation, because we have two types of distillation: simple distillation and fractional distillation. Simple distillation involves the separation of liquids that are mixable by simply allowing one to evaporate or turn to vapor, and they collect it through a tube. So what I'm saying in essence is this: when we talk about simple distillation, what should come into your mind is two mixable liquids that have different boiling points. And for it to be simple distillation, it must have different boiling point that is wide enough. The differences in their boiling point should be wide enough to be approximately 25 degrees centigrade or above. What did I say? 25 degrees centigrade and above. So when there is two mixable liquids whose boiling points are different by 25 degrees centigrade and above, all you need to do is you put them together in a beaker, in a container, add water, put heat on them, put fire under them, and now connect them through a pipe, what we call a condenser, to another container. Now, as the heat grows, as the heat increases, when it reaches the boiling point of the one that have the lower boiling point of the two mixable liquids, the one that have the lower boiling point will start boiling. As it start boiling, to start turning into vapor. And as it start turning into vapor, what happens? Those vapor will start rising out of the mixture. As it rises out of the mixture, it will now start entering through that tube. As it enters through that tube, it will now condense, because that tube has what we call a condenser, a cooling system. That cooling system will cool it down. That's what we mean by condensing. It will cool it down. As it cools it down, it turns again into liquid, from that vapor into liquid, and then it will fall into another container where it will be collected in its purer state. So you see, we were able to separate these two miscible liquids by virtue of understanding the differences in their boiling point. So what will remain is the one that has. So what am I saying in essence? What I'm saying in essence is this, that in the case of simple distillation, two miscible liquids that have different boiling points are heated up in such a way that the one that have the lower boiling point will start boiling first. And when it starts boiling, what happens? It will start turning into vapor. When it starts turning into vapor, this vapor will start rising. As it starts rising, what happens? It will start passing through this particular pipe, this particular glass pipe that is covered by a cooling system. This cooling system is known as the condenser. This cooling system allows it to condense back into liquid form and then collected. It will now fall into another container where it will be collected, leaving behind the other liquid that has what? That has a higher boiling point. That is what we know as what? That is what we know as a simple distillation. So I hope you understand that. And understand, when you are defining simple distillation, do not forget to mention that it involves two mixable liquids that are different in their boiling points, are at least 25 degrees or above in difference. Do you understand? Now let us move into the fractional distillation, which is another one. There's no more difference in this area. It's a little bit more complicated, more intricate, but it's almost the same principle. Now, fractional distillation is just the same thing as simple distillation. The only difference in fractional distillation is this, that it involves mixable liquids that have what? That have boiling points that are smaller than 25 degrees centigrade, that are closer to each other. The boiling points of the liquids that we use fractional distillation to separate are closer to each other, just like kerosene and fuel. They are closer to each other. Two of them are very, very volatile, but their boiling point, like I was saying, when it comes to the case of a fractional distillation, it involves mixable liquids that may be more than two. They may be 3, 4, 5, 6 mixable liquids in one particular mixture. And now, the job of fractional distillation is to find a way to separate them differently. Now, what we are engaging here is a situation where you are going to handle mixable liquids whose boiling points are quite close to each other. They are quite close. Unlike in simple distillation, where the differences in their boiling point should be around 25 degrees or above 25 degrees centigrade. So now, how do you handle it? In handling fractional distillation, the important thing here is to understand that it is the same system, it is the same equipment, but in this case, it is what we call a fractionating column. A fractionating column. This fractionating column is a particular column, a part of this particular beaker, this particular tube, this particular container, where you have put the whole mixture. Now, there's a part of it that you will add some beads, some pebbles, some things that will make it a little bit difficult for the vapors to pass through, so that as they are passing through, only the purest of the vapors can pass through it and reach the right range where it will be collected, where it will pass into the tube. So in the case of fractional distillation, there is what? There is a fractionating column. So understand that the difference between simple distillation and fractional distillation is one, the differences in their boiling points are closer in the case of fractional distillation, while in the case of simple distillation, the difference is, now that you understand that in simple distillation, what you are facing is two liquids whose boiling points are wide apart in a way that they are approximately 25 degrees centigrade or above. You can now say that first, the differences in the boiling points of mixable liquids in simple distillations are wide apart, such that they are approximately 25 degrees or above, while in fractional distillation, the differences in their boiling points are close enough. They are closer, and now there is a fractionating column placed on top of the boiling mixture, the mixture that you are heating up, on top of it there is a fractionating column that makes it more difficult for the vapors to pass, so that it is only the purest vapor that passes through to enter into the fractionating column, the pipe, where it will be condensed into the container. Now, another thing I want you to understand is that which is collected, that which has condensed and collected by another container, is known as the distillate. It's known as what? As the distillate. So it is important you understand the terminologies I'm using here. Distillate is what is collected, is the product of distillation. Distillate is what? The product of what? Distillation. That which is collected from another container that has been placed on the pipe, where the condenser has allowed the vapor to cool down again. So when the vapor have left the mixture and has condensed and collected in another container, that particular one that is collected, that product that is collected in another container, is known as what? As distillation and distillate. So I want you to understand this, and then do not make mistake whenever questions like this comes in any direction, so that you will understand what distillation is, fractional distillation and simple distillation. Have a lovely day.